Hello guys, welcome back to another video. This is Pranav, and in this video we'll be talking about the topic Hough transform. So, introduction. The Hough transform is a feature extraction technique used in image analysis, computer vision, and digital image processing. So, it was basically developed by Paul Hough in 1962 for detecting lines in images, and later extended to detect other shapes such as circles and ellipses. So the purpose of this technique is to find out imperfect instances of objects within a certain class of shapes by a voting procedure. And this procedure is carried out in a parameter space from which object candidates are obtained as a local maxima in a so-called accumulator space that is explicitly constructed by the algorithm for computing the Hough transform. So, in automated analysis of digital images, a subproblem often arises of detecting simple shapes such as straight lines, circles, or ellipses. So, in many cases, the edge detector can be used, that is, a module in pre-processing stage to obtain points or image pixels that are on the desired curve in the image space. So, these are further portrayed, and due to imperfections in either the image data or the edge detector or vertical elements such as noise and distortion, it is not so efficient. So, however, there may be missing points as well or pixels on the desired curves as well in the spatial deviations between the ideal line, circle, or ellipse and the noisy edge points as they are obtained from the edge detector. So for these reasons, it is often non-trivial to group the extracted edge features to an appropriate set of lines, circles or ellipses. So the purpose of Hough transform is to basically address this problem by making it possible to perform grouping of edge points into object candidates by performing an explicit voting procedure over a set of parameterized image objects. Methodology. So edge detection. So prior to applying the Hough transform, an detection algorithm such as canny edge detection is typically used to identify the edges in the image, and this step helps in reducing the amount of data to be processed and focuses on most relevant information. This particular information is stored as values in our matrix. That is, if you take an image to be processed, it is stored as a matrix of pixels, so it is present in the form of values. So the parameter space representation. In the Hough transform, each point in the image space is represented as a curve or a line in the parameter space. So for line detection, basically the parameter space is typically represented using two parameters, that is the angle and the distance from the origin to the closest point. The angle is theta and the distance from the origin is rho. So accumulator array. So accumulator array is created in the parameter space initially set to all zeros. Each edge point in the image is then transformed into the parameter space, and for every theta comma rho, that is our point in space, combination that passes through the edge point, the corresponding accumulator cell is incremented. Thresholding and peak detection. So once the accumulator array is filled, thresholding is applied to identify the most significant lines, that is our transform, and the cells in the accumulator array that exceed a certain threshold value are considered as potential lines, and the peaks in the accumulator array correspond to the parameters that are theta comma rho of the detected lines. So once you have incremented the values, aligning all the edge points on a particular array, so you can take it as an exceed of certain threshold value when your transform is applied to detect the lines. So conversion back to image space, the detected lines in the parameter space are then converted back into the image space using inverse Hough transform. So the process involves finding the intersections of the lines represented in the parameter space and drawing the corresponding lines in the image. So the Hough transform is a powerful technique for line detection, and it is capable of detecting lines even in the presence of noise or partial occlusion. However, it can be computationally expensive, and especially for larger images or complex shapes or data that is pretty huge, it is very expensive. Various optimizations and extensions have been proposed over the years to improve its efficiency and robustness. Mathematical instance. So let us just study how your Hough transform works. So to detect a simple straight line. So in general, the straight line is y is equals to mx plus c. that can be represented as a point b comma n in the b comma m in the parameter space. So, however, vertical lines pose a problem. They would give rise to unbounded values of the slope parameter m. So, slope parameter doesn't have a bound condition as such, so it can have n number of values. Thus, for computational reasons, your Duda and Hart, two scientists, proposed the use of Hesse normal form, that is r x cos theta plus y sin theta is equals to r, that is our slope of the line plotted into our space, as you can see in the figure. It is therefore possible to associate with each line of the image as a pair of r comma theta, then theta comma rho from the particular plane or set of values in our straight line, that is y is equals to mx plus c. So the plane is sometimes referred to as Hough space for the set of straight lines in two dimensions. So let us take an example here. The following is a different example showing the results of Hough transform on a raster image containing two thick lines. So the left part of it is two thick lines, and the intersection between these two images is seen in the right side in the graph where it is plotted, and the bright points, that is the results of this transform, is stored in a matrix, and the cell value represents the number of curves through any particular point. So higher the cell value are higher cell higher cell values are rendered brighter. So two distinctly bright spots in the previous image are the Hough parameters of the two lines. So from these spots, positions, angles, and distances from image center of the two lines in the input image can be determined. The following is another example in the image of paper that you can see. The edge detection is carried out, and all the lines in the particular page or the wrinkles is also seen or detected through our transform, and it is plotted onto the graph in the left bottom image. Applications of Hough transform. So there are various applications in computer vision and image processing. So some of the key ones are line detection. Hough transform is commonly used for detecting lines in images. That is valuable application that is used in valuable applications such as lane detection in autonomous driving or object recognition and image segmentation. Coming to circle detection, the Hough transform can be extended to detect circles in images. That is, over a period of time, it was developed to detect these kind of shapes as well. So this is useful in applications such as object detection, iris recognition, and industrial quality control. Coming to shape recognition, by modifying the Hough transform, it can be applied to detect other geometric shapes such as ellipses, rectangles, and arbitrary curves, and it is performed as a set of intersecting lines. So this enables shape recognition and object detection tasks. So feature extraction. The Hough transform can be used to extract robust features from images by identifying lines or other shapes. It can provide distinctive information about the structure and geometry of the objects in the image. So other such applications are medical image analysis. The Hough transform finds its applications in medical image analysis, such as identifying blood vessels, detecting tumors, and segmenting anatomical structures. One of the most important ones is document analysis. The Hough transform is employed in optical character recognition, that is our OCR systems, to detect and extract text lines or a specific character from a scanned document. So if you take our number plate recognition module or number plate recognition or text recognition using our digital image processing, so OCR is the main thing that we use, and Hough transform is one of the major applications in this particular field. So in image registration, where multiple images are aligned to create a composite image, Hough transform can be used to detect corresponding lines or shapes in different images to find out the transformation parameters. Coming to particle tracking, Hough transform can assist in tracking and analyzing the movement of particles or objects in videos or image sequences. So, and the applications of this are in various domains that are yet to be explored. So, thank you guys for watching the video. Hope you had a nice insight about Hough transform.